Alrighty, so in this video we're going to go over section 4 of exam number 1 in relation to limit evaluation. So for this problem set, we have 3 problems that asks us to evaluate limits in various different ways that can be applicable depending on the expression that we have. Some methods include direct substitution, where you just take the value of the limit and plug it inside the expression in order to find the limit value. Or what you can also do is manipulate the expression in such a way, to rewrite it in such a way that enables you to plug in the limit value into the expression in case that, like, you know, if you put a into direct substitution, you get an undefined form in that sense. Or just simply multiplying by the conjugate, which you would just take the same expression but like multiply it by its other sign. Like if it have like a positive expression, you would multiply it by its positive sign rather than its negative. But these I can just go over as we do these problems together. So the first limit right here, we have limit of x approaches to -2, x to the power of 4 plus 3x to the power of 3 minus root of x plus 6. So what we can do in this case, we can try to substitute this -2 directly into the expression right here. So what we can do is we can have -2 to the power of 4 plus 3 times -2 to the power of 3 minus root of -2 plus 6, just like that, and then we solve. So we have a -2 to the power of 4, that would just be 16, and then because -2 times -2 times -2 times -2 times -2 just gives you power of 16, and then right over here we'd have 3 times -2 to the power of 3 is just -8 in that sense, and then you have minus -2 plus 6 is just root 4 right here, and then you go along and simplify this even further. So you have 16 minus 24 minus 2, which then should equal, so the 16 minus 24 is just -8, minus 2 is just -10, so we just have -10. That equals the result, or the value of the limit evaluation in this sense. So this is one of the methods that you can do. You can just simply direct substitute into the expression. Now moving on to the second equation, so we have limit of x approaches to pi over 3. So of cosecant x tan x. So in this case, we gotta go back to our trigs and go back to the unit circle and like remember our values. So what we can do in this case, instead of just like directly plugging this into the expression, or and just make it difficult, we can just simplify it, and in order to enable us to easily find the ultimate expression that is for the limit evaluation. So in this sense, what we can do is, so cosecant x is just simply 1 over sine x, or actually, let's leave that because we want to include the limit as well. You want to make sure that when you rewrite a function, you rewrite it with the limit together. So you want to do limit as x approaches pi over 3, just like that, of cosecant x is, if we just rewrite it, it's just 1 over sine x, and then tan x is just sine x over cosine x. So you can just rewrite it like that, and then you combine the two terms together, so the sine x's cancel out, so you ultimately just get limit of x approaches to pi over 3, and then 1 over cosine x. Now we can just directly substitute this into the expression, so we'd have rewrite this again, so limit of x approaches to pi over 3, 1 over cosine x equals 1 over cosine of pi over 3. Now going back to a unit circle, cosine of pi over 3 should just give you 1/2, so you would just essentially have 1 over 1/2. Now if you apply copy dot flip, because you have a fraction divided by a fraction, so we'd have 1 over 1 times 2 over 1, which just gives you 2 for the answer in that case. So 2 should be the evaluated answer for this limit right here. And then 3, so 3 we have limit of x as approaches to 0, and then we have root of 2x plus 4 minus 2 over x. So what we want to do first is we want to direct substitute the 0 in order to see if it's a determinate form or non-determinate form. If we get an answer straight from the direct substitution, great. If we don't, there's another way where we can, another method that we can apply in order to find our answer. So in this case, what we can do is just have limit, you don't have to rewrite the limit when you apply the function by substitution. So you just have root of 2 times 0 plus 4 minus 2 over 0, which gives you root 4 minus 2 over 0, which essentially just gives you 2 minus 2 over 0, which is just 0 over 0. So 0 over 0 just gives us a non-determinate form or indefinite form for the limit. So in this case, what we can do is just apply the conjugate to this expression. So what does that mean? So let's first rewrite the expression. So we have limit of x approaches to 0, a root 2x plus 4 minus 2 over x. So applying the conjugate, you're just taking the numerator of the fraction and just applying the opposite sign on the outside of the expression. So like what I mean by that is like you can just multiply this, the numerator, by the root of 2x plus 4 minus, or sorry, you do plus 2 instead of minus 2 to apply the opposite, and then you do the same for the denominator as well too. So you do root 2x plus 4, gotta downsize this a little bit, plus 2. But this conjugate form is only applicable to like when you have when you have roots within the expression, because when you multiply a root by a root, you just simply get rid of those roots. So it makes it easier for you to simplify terms and just solve for the problem accordingly. So in this case, what we get is we get 2x plus 4, because you have the two roots canceling out, and then you just get negative 4, because negative 2 times positive 4 is just negative 4, over x times root 2x plus 4 plus 2. So just like that, and then you can cancel the x right over here, so you would just have 2 plus 4 minus 4 over 2, or root of 2x plus 4 plus 2. So now you can just have that. But now you can just rewrite with the limit. So you'd have a limit of x approaches to 0 when you have 2 plus 4 minus 4 over root 2x plus 4 plus 2. You want to downsize this a little bit, plus 2 just like that, and then you have, in this case, you have 2 over root 2 times 0 plus 4 plus 2, and then you have 2 over root 4 plus 2, which in this case you get 2 over 2 plus 2, which is just 4 in that case. And then you just simplify that even further, and you just get 1/2 in this case. So these right here should be some of the methods that you can use in order to evaluate limits and therefore get the solutions for those. So yeah, thank you.